Welcome to Easy Math TV. We're going to do an application problem in our Patterns Between Two Numbers series in the playlist on quadratic and polynomial relationships. And this one involves something a little bit unusual. We have a partial payment schedule here on a loan. So there's some missing numbers. It only goes as far as payment number 10 and then it stops. And it tells us basically what our loan balance is and how much of each payment goes towards interest, which is that's just curiosity right there. We don't really need those numbers per se. We're only going to need the X's and the Y's. But the type of loan that we're dealing with here is something called a Rule of 78 loan. And I wanted to make sure that we were doing something that was legitimate, that it wasn't just made up. When you're dealing with this type of loan, the balance goes down by a very specific pattern, and I want to discover what that pattern is today. So we have two goals. We're going to discover the pattern of the loan balance over time when the interest payments follow that pattern, that thing that we call a Rule of 78. And we're going to, like, how do you decide that? When all you have in front of you is these numbers, how do you figure out what that pattern is? And we're going to do that. And then we're also going to get an equation for that. Once we have the equation, we call that a model, by the way. When you find the equation or the model that represents that pattern, we're going to use that model to find what the balance will be at payment number 16. Okay, and it's not here, so it's missing. So we need to be able to fill in that missing payment, that missing balance. All right, so those are our two goals today. And if you are familiar already with our series on quadratic and polynomial relationships, everything that you see here should look familiar. We have our x's and our y's, and right next to the x's, I have a column for delta x, and right next to the y's, I have a column for delta y, and then I have a column for delta delta y. So if you're not already familiar with those, you'll want to go back and review the introductory videos that I gave on quadratic patterns between two numbers, and go ahead and review the very beginning of this playlist. If you kind of jumped right in the middle here, then you may have missed that. So you'll want to go back to the beginning of that playlist on quadratic relationships. But if you've already seen everything up until this point and you're just ready to go, then let's just get started, okay? All right, so we're going to fill in our delta x's. So let's start with cell A5. As usual, we're going to be subtracting two consecutive x's. So starting with the one that's current, the one that's right next to us is in B5, and subtract the one above, B4. So that's equals B5 minus B4. It's always going to be the current row minus the row above. And so change in x is equal to 1 because the payment number went from 0 to 1. So that delta x is 1. And if we just kind of fill down, we see that our delta x's are in fact constant. They are 1 all the way down. That's what we say constant when we are referring to something that does not change. Delta x is always equal to 1. Let's calculate our delta y's. So in cell F5, we subtract. So we're going to take equals. We're going to type equals, and then we're going to subtract the current value of y, which is D5, in D5, minus D4. That's D as in David, by the way. So again, in cell F5, I am typing equals, and it's the current y value equals D5 minus D4. I skipped column E, by the way. Column E was just a space. I don't know why I did that. I just did. So let's fill down. And as we can see, delta y is not constant. It is changing as we go. In fact, so your balance gets paid off more and more the further you go down. So the later in our later payments, it looks like we keep putting more of our monthly payment towards the balance and less of the monthly payment towards interest. So actually, if you wanted to know what your monthly payment is, um, the first thing we would need to do is make that delta y number there positive, so $81.43. So basically, I would get a calculator out. We can do this on the calculator. So 81.43 plus 134. So that's the number in column C, 0.40. So balance plus interest is $215.83. It looks like that's what our monthly payment is. And by the way, you should get the same number if we jump down to the next row and we do 87.03 and we add to that 128.80. Again, it's $215.83. So in any of these rows, the interest amount plus the delta y there should equal $215.83, provided that you change your delta y number to a positive number. Okay, that's interesting. All right. So the point is that delta y is not constant, so this is not linear. Okay. That is our conclusion right there. Then we go to our delta y column, and I have to go down one row because we need to be able to subtract two delta y numbers. So if we're going to subtract f6 minus f5, then we need to be here in G6. So in cell G6, we're going to type equals, and we're going to do f6 minus f5. So two consecutive delta y numbers are getting subtracted. Hit enter and fill down. And lo and behold, I'm just going to keep those highlighted so you can see those are all the same number. They're not like a whole number, but they are the same. Negative 5.6, negative 5.6, negative 5.6. So that is constant. That is something we call constant. And when delta y is constant, we have a quadratic relationship between x over here and y here. Those two things have a quadratic relationship because delta y is constant. So let's go ahead and insert a graph. We're just going to do a smooth graph here. And it's kind of hard to see the curve. If we had more numbers, we might see it a little more clearly. But we can go ahead and add a chart element, add the trend line. And the linear one almost looks right, but you can actually see some of those dotted lines there. If we go to polynomial of order 2, it's actually much more perfect. So like it's a perfect match. So I'm going to hit display equation on chart. And, just because I have a hard time seeing small text, small print, I'm going to, instead of make that 9 points, let's make it a little larger. And of course, it didn't work the first time, so let's try it another time. Make that font size bigger. All right, there we go. So there's the formula. This is what we call, it's got 3 different terms. You could call it a formula, you could call it an equation, or you could call it a model. It is, we're going to use the word model. It is the model that tells us how to calculate the balance for any particular value of x. So keep that visible there. And I'm just going to pick any old cell down here and make my value of X the one that we're asking about. So it wants to know what the balance is at payment 16. That's what the question asked. Payment number 16. So, oops, how did I do that? Okay, I didn't mean to erase stuff. So, payment number 16. All right, 16 is X. And right next to it, let's just calculate this. So it's going to equal and negative 2.8 times, and then the number in X is B16 to the second power. And then we have minus 78.633 times 16 again, times our B16. Oh, that's interesting. The number in B16 is 16. Oh, interesting. And then add to that 3,500. Okay? So that's what the equation tells me to do. Take negative 2.8, multiply by my x squared, x to the power 2, and then subtract 78.633 times our value of x plus 3,500. And the value of x is I'm referring to the cell B16 each time. Okay, so just down here I just happened to take row 16, and at the 16th payment, by the time we make that payment, our balance should be $1,525. And let's just round that to the nearest cent. So it's $1,525.07. That's what our balance will be at payment 16. So that's what the purpose of an equation is. The purpose of the model, the trend line that we came up with that fits our data, is so that we can calculate missing values. All right, that's the whole point of it, is to calculate missing values. So our payments continue to pay off our loan. We don't know right now how long it would take to pay off the loan. We could actually we could do a fill down over here. Basically, I could just highlight this whole series of numbers. Hang on. So that whole block of numbers I could highlight, and Excel will continue to use whatever pattern has been established to keep going. And you'll notice the balance is still not zero, right? So I have to keep going. There we go. So once you get to that zero, looks like that's how long it would take to pay off this loan, is 24 months. Anyway, I was just curious about that. But we've answered the question. So if you are finding these videos helpful, please like, subscribe, comment down below, share them with other people who are taking business math or are trying to learn a little bit about finance, a little bit about applied mathematics, and hopefully it's helping you to learn some math as we go. So I'll see you in the next video.